Hi, welcome to what I guess I'm going to call Knife Lab, where I experiment with some different things that relate to knife making and tools in the shop and stropping compounds and all that. This will be the first long-form videos that I'm doing. But I wanted to talk about the belt grinder design that I'm going to do as open hardware and kind of where that stems from. So there are good belt grinders out there. I've had some, I've used them, I've sold them. My number one complaint would be in sort of a lack of rigidity, particularly in the designs that hinge, and I know a lot of people want a machine that hinges. I'd rather not have that. There's just too much weeble wobble, and over time especially it gets better, and I find myself constantly adjusting and things aren't 100% square. So I wanted to build my own that really did the things that I need to do the way I want to do them and is sort of rock solid. And so my particular idea for design stems from an observation, which is this somewhat unusual U-channel. It is a standard hot roll mill item. It's just not carried real widely, so you got to look for it a little bit. And I'll put the specs on the Knife Lab page for this whole design. But it's about 5/8 deep or tall, and then 2.5 wide. And in particular, too, you have your square tube. Most knife grinder designs I see typically struggle with the issue of how to get telescoping tube to work, given that there's a weld seam. Or is it on this guy? Here it is on the inside there. It's a little bit hard to see. Let's see if we can get it. You can see that bump there. So either you got to go to the trouble of getting rid of that or fitting very awkwardly, and then also in terms of welding something up, you have the issue of the round corner and so forth. So the observation that I had, I don't know when, a long time ago, but I sort of had it in the back of my brain, was that with this U-channel, it fits very snugly onto the 2.5-inch square tube. And so by doing this, you get a nice fit that'll allow you to slide in and out the square tube for the mast arm that holds the platens and things like that. And then potentially you can do several of them. And of course, this is heavy duty 1/4-inch wall, 2.5-inch square tube. And in the particular configuration that I'm using, basically you're going to connect to the fan with like this, where this is plate and it's welded on there, plug welded, and then this side in and out, and we'll put a knob on there to hold it in place. But just on its own, get the mill scale off it, grease it up, it's incredibly strong and rigid. And so that's kind of the light bulb that the rest of this stems from. And then I'll get set up here and we'll focus on cutting some of the plug holes and welding up the first parts of the plate. This is the large plate that makes up kind of the spine of the grinder. Sits like that. And we have these U-channels that add structural support and provide the spacing for the arm that supports the actual grinding platens and all that. This is 1/2-inch plate. I think 3/8 because it was on sale. You could definitely use 1/4-inch plate, and then a couple extra remnants to help it provide structural stability. I'll pre-apologize for the welding in this video. It's going to be terribly ugly, but just the setup that I have handy at the moment. And I certainly would never promote myself as a quality welder. I'm going to clean this up in a sandblaster just to clean off some of the paint mill scale rust that's on there. You could just as easily use a grinder and everything. This is just a setup that I have handy. Two quick things on sandblasting while I got your attention. On cabinets, I mean, really it's only me in my shop, so I don't have to worry too much, but I've been in some other shops where this is always a problem. Store your gloves open so they dry out or partly dry out, and use inner gloves so there's not some big greasy sweaty mass that gets built up in there. Usually the smell from these alone will drive everybody out of the whole shop. So we got those cleaned up in the sandblasting cabinet well enough for the type of craft welding that we'll do here. I like acetone as a general purpose solvent around the shop, and we'll use that to just clean up. I like it in these little laboratory bottles. It doesn't evaporate. You can leave it in there for a long time. All right. Naphtha too, depending on what the purpose is, but that does leave a little bit of a residue. So we'll wipe these down. All right, and these are going to be plug or slot welds, depending on how strong I feel like the joint needs to be. This isn't exactly a structural type application. I mean, we want it firm and so forth, but the layout is something like this. So we have our top piece, and then we have a second piece here. And because of these are hot roll, you know, their dimensions are not absolutely precise. That's a common problem when you're building these belt sanders, either putting tube in tube in the weld seam or all kinds of different configurations. So this offers some structural advantages, and because it only touches on 2 points on top and sort of the hump of the below it, and then the flatness of the plate sides, it has a very tight fit. Even some of the nicer ones that cost a few $1,000s. I sold one, and overall it's a great machine, but, and you know, that's my complaint is the buts. This one I want to be able to lean into this thing and not have it move at all. It's just how I use tools. I tend to be the harder type user, and especially I just want something where I can set it up, mount it, and it's just never ever going to move. So I'm going to start with a weld on the top seam here, and then depending on how strong that feels, I may do a couple little plugs here. All right, so after a little value engineering thinking here, we're going to try and ease our fabrication a bit. And I've got this mounted up on the drill press. We're going to drill the plug holes on the inside of the U-channel. That way we don't have to drill the thick plate, and then if we need to drill them on the other side, we'll drill them through the thinner plate. And I think we'll be able to do this, and it'll work out a little bit easier in terms of fabrication. So let's get these here. I just marked them out. They're a 1/2 inch on each end, every 2 inches in, and then a 1/4 inch down from the top. The holes will be in the drawings if this all works out the way I think it will. Okay, so we're not going to get away with the plug welds. They're just not strong enough. There's not enough penetration in that size of the hole and so forth. So I clean this up again with the wire wheel just to get everything off there. And then we're going to have to drill this guy to make the holes, make them a little bit larger, about the size of the width of this. A couple people on Instagram have asked about these. I use them in some of the videos. This is a ruby quartz stone. I use this constantly. It's extremely handy. I find it a lot more useful than the Arkansas stones or some of those. The ruby is extremely hard. The quartz is maybe equivalent to a 3,000 grit, give or take. Or no, I guess, sorry, the quartz is 10,000, ruby's maybe 3,000. Perfect for cleaning up a lot of stuff. There's like a Chinese import version, which is not nearly as durable. And I think the ones I like come out of, I want to say Romania or Ukraine. You can get them on eBay. I might end up stocking them in the store if people ask about them. They're not particularly expensive. I usually buy them several at a time, and they last quite a while. All right, we're just laying out the holes here every 1.5 inch, give or take. Again, these are just for the welding holes, so the layout is not crucial. This is just a cheap 110 volt import MIG welder, and a lot of people don't like these. You know, for me personally, return on investment on this thing, it's portable. You can plug it in anywhere. I mean, absolutely through the roof. So, no, you're not going to be welding aircraft or anything life-saving with these. But for a lot of the simple weld projects I do, it's really hard to justify anything else. All right, so we'll punch these holes, drill a pilot. Okay, we got our pilot holes drilled. Now we'll move on to the larger holes for the plug welds. And the positioning at this point is mostly aesthetic, although on the next piece, the fit for the slide, the tubular steel will matter quite a bit. You want that to be real snug. So while I tack this in place, I've got a little shim in there just to give us some clearance and stop potentially some of the warping while it heats up. And the important thing is that the hole doesn't clear the bottom of the U so that you're getting into that surface where the square tube is going to ride against. That'll be a pain in the ass to clean up later. So you want to make sure your holes are north of that space. We got those welds done. They're not going to win any beauty contests, but there's good penetration and a nice square joint. There's a little bit more of a gap. I mean, I had the shim in there, but the heat exposed it a little bit, so I don't actually think that's a problem because the square tubing is a touch oversized. So we're going to test the fit on that right now. It's good. It's still snug. Probably a little bit of weld spatter there, but nice and tight fit. So this is kind of how the puzzle pieces fit together. Flat side here, on the butt side there. And this is where the fit matters a lot. I'm going to score the line for where this sits. And we have a little bit of fudge room. We need to drill the holes, so we need those to line up well. But of course, when we set this up, we can fit it all together while we weld. Wash, rinse, repeat. These plug welds 4 times, spacing out this one to the square tube, and then a third to the square tube, and then finally one all the way at the bottom. Same spacing, 0.153 inches up from the bottom of it, and then ½ inch from each end and 1.5 inches spread in the middle. That seems to offer a really secure joint. Unfortunately on this we don't have the luxury of the being able to weld from the top, possibly because of the way the bottom sits. You can see there is this gap here, so we might be able to get away with putting a bead there, but I'm going to see how the plug welds feel, and then if need be come in and touch that up further. I really don't want to get in the business of die grinding or anything on the inside here because it's just so tedious. So that gives you a sense of the sliding fit. One of the reasons that it was so important that the holes be clear of the interior here is obviously so you're not welding on this. I left this in while welding so that the fit was pretty tight, but not so tight that it would be difficult to put in as everything expanded and kind of shifted. But you want to make sure you don't actually weld this to the plate by accident. You can tell it's free, but stiff. And of course this still has the mill scale and everything on it, so as it gets burnished with the wire wheel and I think greased up, we'll have a real nice sliding fit. So we're set up here now to do the OD operation, and this is one of those carbide inserts, which is not really appropriate for this soft aluminum, but it'll do just fine. And all we're looking for is just shaving off the outside. This is nominal 2-inch. We just want to touch off and fix any issues in concentricity. I double checked our setup with the indicator, and we're even we're within a ½ thousandth along the length, so we're much closer than we actually needed to be. If you don't have a lathe and you don't want to go through this trouble, I mean, these materials were about $15, so it's a bit cheaper than the option. But I've heard good things. I can't endorse them because I haven't used it. I heard good things about I think it's Oregon Blade Maker on eBay and maybe some of the other shops out there. We're finally finishing up this operation. I'm leaving this on the center again because I don't have the steady rest setup that would be well suited to this. Got that lined up, and now we're going to go some of the way, but not all of the way. Up with a quick quick chamfer on the edges. We're over here at the bandsaw, and I got this wrapped in painter's tape just to help minimize the marring on it, and then I cut in the recesses where the parting operation was done, so it should make pretty quick, clean cuts. Let's see. I got 3 layers of painter's tape on each of the jaws. It's not a perfect solution to marring, but it gets you pretty close. We're going to want to make sure this seats all the way against the face there, and we'll give it a little snugging, turn it a little bit. Okay, yeah, I think we're pretty good. I'm going to double check it with the indicator. Just going to face off the bandsaw cut. Going to drill a quick start hole before we bore out the recess for the bearing. Here's the 608 double Z bearing. This is just standard skate bearing. You can order these 10 at a time. I think they're under $1 a piece. The inner diameter is 8 millimeter. We've got it set up here with an 11 millimeter drill just for clearance, and then the axle will run through the inner races of the bearings for these pulleys. So now we'll do the drill operation. Here we are, we're through. Now we'll get set up for the bearing recess operation. Got our boring bar set up. We're going to go from the outside in just so our dimension can keep checking it. We're about halfway there, and we are starting to run into clearance issues, so we're going to plunge a little bit from the outside in. Yeah, we got some clearance problems here. So clearance-wise, we're just not going to make it that way. There's just not a way to cheat it. It's too tight on that size boring bar, and I just don't think I have one smaller. I have one, but I don't have the bits for it. So this is a 19 millimeter end mill. We're going to try and make ourselves enough of a recess here so we can finish boring. This, of course, is not totally concentric, but that's why we can clean it up with the boring bar. Snuck up on just a touch over 7 millimeters, so we'll have a little bit of clearance from the edge here for the bearing. You know, all this is manual lathe work. If I had a DRO on this lathe or so forth, it'd be quite a bit easier, a bit faster here, but this is how the lathe is set up. Like I said, I do intend to CNC it. I just haven't had the chance to do that yet. So now we're going to sneak up on the OD for the bearing. And because of that pocket we did with the end mill, our clearance issue is relieved. We've got it in there, and then we're right, can't quite snug it in there, but I think on the arbor press we'll be able to fit that all the way in. So that'll wrap up that side. Now we flip around, do it again. Just going to put a quick chamfer here on the edge. Just using a file because I don't have a chamfer tool that'll fit in there at that angle in this setup. So that finishes off it, and now I'll go over the arbor press, load in the bearing. So here we are after the first afternoon of belt grinder building, and I've got the finished pulley 1 here, and I got the bearing with a little bit of the blue Loctite on there, and we're just going to go ahead and crank that down. Okay, there we go. Nice fit, nice clearance, looking pretty good. So I'm pretty pleased with that. And then we also have the base here. We got both those welded. I checked the fit several times. With this guy right now with the mill scale on, it's quite snug, which is good. So we'll be able to tighten that in and throw in some knobs to lock it in place once it's there. And then just got to do one more of these here, and then the base here, and then this 1.5-inch flat stock will get turned into that upper rail in the drawing to support the top bearing. And here's our top bearing. That would make a 3-inch bearing there to compare to the 2-inch. So these will be part of the platen assembly. So here are those members for the platen. So in essence, I'm not exactly sure whether I'm going to go to the trouble of milling these or not. I might, just because I have the CNC mill and I can. I will include the drawings for the whole locations, but in essence this will mount up there like that. This guy will go here. And these are just 12-inch halves from the metal store already cut, so it saves you the trouble there, very inexpensive. That'll wrap up this first video for day one or afternoon one, and not too bad. I mean, including a trip to go get some more MIG wire, so moving along pretty quick pace. I think this is definitely a weekend type project, not including sort of sourcing the materials and maybe some of the prep. But anyway, I'll see you again next time.